Hi, this is Dr. Judd. Today we're going to talk about tangent lines. We're going to find the derivative using limits, and then we're going to find the tangent line and apply it. So the example today will be about cotton candy. So here's some cotton candy, and as you can see, the amount of cotton candy decreases over time. And the amount of cotton candy, I've got a cotton mouth. Cotton candy left on the stick is going to be given by V of t as 200 over t plus 1 cubic inches. So initially, at time 0, there are 200 cubic inches. We can figure out how big that is. Eventually, as t gets larger and larger, it becomes less of an issue. Eventually, there's a little bit left, it's kind of sticky, and that's why this never quite goes to 0. But t is in minutes, and our question here is going to be at 9 minutes to find the tangent line. First, though, I want to find the derivative in general, and even to have an idea what that means. This is not just an abstract function, finding the derivative. The derivative is the slope of the tangent line, but what is it? So we're going to do that first, then we're going to find the tangent line, and then we're going to take a look and see how that is useful for us. So to find the derivative first, we use the difference quotient. There it is. This is the limit as h goes to 0 of v of t plus h minus v of t all over v of h. I'm sorry, all over h. So what do? We take the limit as h goes to 0. V of t plus h, remember how that works? T plus h goes into the function everywhere you see a t. The only place is right there. So we have 200 over t plus h, that's parentheses, plus 1, then minus v of t, which is the same thing, but without the h, all over h. Now if you look at that, you say, that's fractions within fractions. Fractions within fractions is not very pleasant. So we have to fix that. First thing we're going to do, though, is take these two fractions and get a common denominator. This thing and that thing are different, so if I just multiply this one by that one, I can get the limit as h goes to 0 of, keep the h on the bottom for now, I'll multiply this over here, so I have 200 t plus 1 minus that one on here, 200. This is t plus h plus 1. And then right below it we have t plus h plus 1 and t plus 1 multiplied on. Now I'm going to simplify the top, I'm going to multiply everything out. But the bottom, I'm taking this divided by this, and then I'm dividing again. So if I took 6 divided by 7, and then divide by 2, what do I have? Well, the 7 and the 2 are on the bottom. So these two are really both on the bottom of the fraction. Something divided by something, and then divide it again. This and this are both on the bottom. So this is equal to the limit as h goes to 0 of, the top is going to, well, the bottom then is this, this, and this all multiplied together. I'm not going to multiply them out because I think, honestly, they will cancel better as factors. The top, I have 200t plus 200 minus 200t minus 200h minus 200. So as I said, some things will cancel. There's a 200t, a minus 200t, a 200, and 200. So if I do that, I have minus 200h, and on the bottom I have an h times t plus h plus 1, and then I have t plus 1. So the h can divide out of the top and divide out of the bottom, and at this point we have gotten rid of all of the pieces that make this discontinuous when h goes to 0. Because now the bottom is the only h, and if you plug a 0 in there, it still works. So let's plug the 0 in. So the derivative is minus 200 over t plus 1 squared. Now, what does that mean? The derivative is the slope. And it's tricky to understand what that means. It's a changing of the function with respect to time. As t goes on, then what's happening? And we can probably figure it out best by looking at this very beginning one. This is the change in the volume divided by the amount of time. And as time goes to 0, this becomes an instantaneous change in volume. So this is the rate of change of volume with respect to time. Well, what units is it going to have? It's the units of volume divided by units of time. So this is going to be cubic inches per minute. Now, that's not really the end goal. The end goal was to find the tangent line at 9. So we need to find the slope when t is 9. When t is 9, plug 9 in. So 9 plus 1. This was chosen for a reason, because 9 plus 1 is 10. Squared is 100. I get minus 2 cubic inches per minute. And that's the slope of our line. Now, what is the tangent line? It's going to be, say, L for line of t is going to be minus 2 times time plus something. How do you find that something? Well, if I use a point slope form, I can just plug in the original point. And if I haven't, then I have to figure it out. But what I want to do now is then figure out what that original point is. At 9 minutes, how much cotton candy is left? Plug a 9 in here. I get 20. So at 9, when t is 9, v is 20. So in other words, when t is 9, the whole total amount is 20. So this better balance out. Do a little algebra here. This is 38. That's the only number that's going to make this work. So my tangent line is minus 2t plus 38. And there you have it. What does this look like? Well, the graph looks kind of like this. And right there is the tangent line. Notice that it doesn't really look like it's got a slope of minus 2. Definitely it's minus, it's going down. But the scale is relevant. So this is really stretched out more if you want, and then it would make it much steeper. This is also much taller. So keeping track of your scale, this is a minus graph. The y-intercept is up here, which is pretty good. And then that's it. Notice this is 200. This is 38. And this is Dr. J.